Good morning, everyone. We'll give it a minute for a few additional folks to join. Looks like some more attendees are jumping in. Going to send a quick chat test. And one of the attendees, please confirm whether or not you see my chat message in the session. All right, thank you, Lucas. Thank you, Merle. All right. Thank you, everyone, for joining us today. The webinar is going to encompass a new feature in the ASE2000 Testset. That feature is the simulation of multiple RTUs. We've developed this feature for a customer that was performing a SCADA cutover project. And I'll go into those details here shortly. Let me introduce myself. My name is Larry Price. I'm a sales engineer with Applied Systems Engineering. I'm also responsible for customer support on a multitude of our products, as well as training on products. I've been with ASE since 2016. And some of you I've actually trained in person. All right, let's begin. So prior to ASE 2000 version 230 and 231, which is the present active version that we've released, we had the ability to simulate RTUs, simulate a master, multiple protocols, both bit and byte protocols, but there were certain limitations with that. TCP communications, when selected, we had the choice of a single target IP address and port. And if there was any testing requirement for additional RTUs on different port assignments or different IP addresses, the user had to navigate to the upper menu and change that criteria and then retest. So a bit tedious and a bit cumbersome when you had a multiple or large quantity of devices to test. As far as scalability, that was also limited. ASE2000 prior to 2.30 in either task mode or exchange mode would only support testing for a limited number of RTUs. It just really wasn't feasible or practical to say test 50 RTUs or 100 RTUs or 200 RTUs, but now we have that capability. And in those modes of operations prior to 2.30, you could support multiple instances, but it tended to be a little bit processor intensive. So there was some performance issues that might be notable depending on your particular hardware or laptop. And we have the ability now to support up to 50 RTU simulations with one instance. And also, I'm sorry, not also, but with 2.30 now, we have multi-channel support for both master and RTU simulations. We support RTUs on a single channel, so we could have, for instance, multiple IP addresses on the same port assignment, or we could support same IP address across multiple ports. And another feature that we have are presently offering is the ability to encapsulate serial traffic over TCP/IP communication. So this is desirable and for situations where you have a terminal server at the end of your circuit and you need the ability to test that. Now, your front end processor or SCADA, mind you, must be able to communicate with serial protocol for you to take advantage of that feature. It's not something you could deploy at will. Your front end processor has to natively support those bit protocols. However, with the present feature set, you can validate all of your RTU configurations on a circuit before you go live. We also have a TCP splitter to support multiple protocols on the same channel. Prior to 2.30, if you were to test a particular protocol, you could only test one protocol at a time per instance. Now we support multiple protocols in uh, in your test scenario across that channel. And also with our SCADA cutover capabilities now, you can scale up readily and rapidly with the deployment of a VM and take advantage of our feature set. Unlike the previous scenarios with task mode, setting up an RTU configuration or utilizing exchange mode and defining your configuration and RTU parameters through the exchange list, we now have CLI support. That CLI support allows you to rapidly configure a environment for testing purposes and create what we call an A2K project file. And with the CLI, you can not only create that file, but launch an instance with all of those parameters readily available, which I'll be demonstrating here shortly. A common network topology on screen that we see in today's environments will be, you've got a SCADA control center, head end, front end processor, various network connections to downstream devices. Those devices vary in configuration and capability. Some devices are TCP IP. They could be on different port assignments. They could have unique IP addresses, and obviously they have unique station addresses. Other network segments may be TCP IP routed to a terminal server device, which integrates serial devices downstream onto your head-end platform. Those serial devices are comprised across multiple COM ports. So serial communications can only connect through or to the network via a terminal server to convert the media from serial to TCP IP communications. And there's some challenges with testing those different segments prior to 2.30. Prior to 2.30, as I mentioned before, you had to specify the desired environmental parameters such as TCP IP communication in the test set or serial, and you could only test and simulate on those individual circuits in an isolated fashion. With our test set now, in the absence of the individual devices, you can simulate a multitude of RTUs, as I mentioned before. Each instance now in post 2.30 or the present 2.31 version, you can support up to 50 RTUs per instance. Now, there would be some obvious limitations with laptop or desktop hardware when it comes to the processor and the ability to simulate that number of devices, but we also have VM support. So with VM support, you can rapidly scale up accordingly to simulate your network configuration and test. With the 2.30 or 2.31, we can now, or a user can now elect to run a byte protocol across TCP IP encapsulation. And as I stated before, this is to validate those end devices that are serial communication only capable across your networks. Now, mind you, you need to have IP connectivity wherever that PC or laptop resides or the VM resides with your network to verify that. And I'm just going to pause momentarily. I don't think that this session will last a full hour. And as a presenter, I cannot see all of the questions on screen. At the end of my demo, I'll do my best to answer any and all questions that you may have. And if I do not get to all of the questions or do not see all of your questions before I end the session, I'll follow up an email. So today's demonstration will be comprised of a Windows 10 laptop that I'm using. It has ASE version 2.30 installed on it. And I'm only going to be running 2 instances for demonstration purposes. One instance will be my master. So in the absence of an actual FEP or front-end processor that's communicating downstream with scans, controls, all of these communications and responses that we want to verify for, say, a cutover project or just simple analysis before commissioning. And one RTU instance. My single RTU instance is comprised of 50 individual RTUs with unique IP assignments. I'll go through the configuration for that. I'm using my Microsoft Loopback adapter because I don't have a physical network here that I could test through. And as you can see, it's just a single PC, 2 instances. So let me flip over to my individual session. So when you install the newer version of ASE2000, so it would be 2.30 or 2.31, we provide sample exchanges for you in CSV file format. These CSV files are used to create and generate a project for large-scale simulation purposes. Once you utilize all of the defined .csv files to create your environment, it will create a project file. That project file is what you see up top. DNP is my protocol .a2k file. So the .a2k file is just a project file. It's utilized by ASE2000 to create your test environment, be it a test environment for the master with defined RTUs on it or simulating defined RTUs with configured points, etc. So in there you have a communication file. I'll just show you the example. In that communication file, some of this information should look familiar to you if you've ever imported a point list in ASE2000. We have default schema nomenclature in there. And in here you have point configuration. So let me expand that out a little bit. Points per or bits per analog, bits per digital, MCD, pulse counters, analog point simulation parameters, and then you've got your RS-232 parameters. Or in this case, if I was using TCP IP, I would have a port and an IP assigned to it. The configuration process for serial communication versus TCP IP communication is very similar. In there, once you've created a basic template, let me just show you how you create that template. I'd start with an instance, select your protocol, the MP3 LAN WAN, and then you go to your file menu option. In the file menu option, you have the export option available, and this would be the properties info. The properties info, once you have elected or selected your protocol of interest or protocol that you desire, it will create basically a template for use or with your project file. So in there, let me show you what I've done. It creates, I went to LAN WAN Ethernet option, and this is my web demo today. And in there, all that I did is once I exported all of the default parameters with the desired bits per point, etc., I specified my port that I wanted to use for communication testing, and my protocol is selected up here, DMP3 LAN WAN. Now, I mentioned that you can test across multiple ports using multiple IPs, so these are placeholders. In the project file itself, you have two main files. You have your communication file that it uses to set up the basic environmental parameters, your protocol, some communication essentials, and then you have your index file. Your index file will list all of the RTUs. Let me go back to the sample or sample exchange or examples we have. And in there, you'll have a list under the index file of all the RTUs applicable for that test scenario. So in our example folder, that's part of the default installation, here you can see there's two RTUs, RTU1, RTU2. Once you've added those RTUs into your indices and specified the number of RTUs that are there, then you would go to your actual template, which would have some point lists there. Your point configuration, CSV has a name field, and hang on, I think I've highlighted one. Yeah, it has a name field, which is a unique name, not critical for testing. You can use some default information, but what is critical is your protocol, your channel. So a channel is a new parameter that you'll see in the test set, both in task mode and exchange mode. There at in that field, you could specify the IP and port associated with that RTU. Here we have the RTU ID, and we've got some mapping in here. So some of you who are present ASE2000 Testset users will recognize that you can map outputs to inputs. So there's an example here. Here's my point types, the point IDs. So I've got 16 digitals in this scenario. And then if you scale or scroll over rather, you've got a value section and an interval section for your points as configured in here. So I can specify an interval of change every 5 seconds, etc. If that field is absent, then it's going to simulate the designated value in the values columns, AC, AD, AE columns. You can continue to cycle through those, or actually it'd be cyclic, or you could just specify static value if desired. So in this scenario down below, I've got some analogs, and I'm simply alternating between 11 and 12. Here, up here, my digitals are toggling. So we have support for all of the standard objects in there. So in this environment, I've got some 2-bit binary inputs, single-bit binary inputs, some outputs. So you could actually test all your output controls from your front-end processor and validate that. And that's the basic layout for your RTU configuration. Go back to that folder. So in the example file, we've got some PG&E protocol specific communication parameters. These features that I'm going over were developed for PG&E. Here's the RTUs and their associated configurations, and the indices specifies the actual RTUs that are part of the simulation. So RTU1, RTU2, and the communication file. In our README file, you'll see under the help menu, the help menu is inclusive of the operator manual for ASE2000. It's embedded with our application. In there, it'll tell you how you create your project. And to create a project, you're basically going to start a command prompt or a Windows prompt. And in there, you will navigate to the directory where all of your core files are, the communication file, the index file, and the RTU configuration file. And you're going to run this, and it's verbatim. You just copy paste directly into your Windows prompt. Here it's mapping the path, it's specifying the core files, and the output is a dmp.a2k file. That is what I'm using for today's demonstration. And the next command that you are required to enter in the command prompt is right here on screen, and this will actually open the project that you created. So the first part is navigate to your directory, create the project. The next step is to open the project, because it's not like what we used with task mode or exchange mode previously, where you go to a shortcut and open it. You use the command prompt and the command line interface to launch that project. And then you select your mode of operation, and the rest of the operational controls would be the same as previously used in earlier versions. So in my command prompt, you can see I've entered the command to open the project I created, but I wanted to show you at first how many IP addresses I've assigned to my adapter. I'm utilizing the alias IP function. And as you can see here, I have a multitude of IPs available on that adapter: 10.10, 10.00.10, all the way through 10.00 through 59. And these are representing the IP and subnet for all of my simulated RTUs. And let me show you how you launch an instance. I've already have 2 sessions up and ready, but I just wanted to demonstrate how you. Oop, it doesn't like it because I'm in there. But let me close that. Yeah, let me just close that and go to the session. It's just 3 command lines you enter, as I showed you before. The first one's going to open up. By default, everything will open up in master mode, just as before with ASE2000. And you'll select RTU mode. This is the session I've created. Let me just expand it for your needs so you can see this. In there, I've created multiple RTUs. So this is RTU1. I've got some binaries, some analogs, 2-bit binary inputs, some controls in there available. As you can see, the transmit flags are not enabled. I'll just use those for testing. They'll respond accordingly. The test set always echoes controls. And if I scroll down, you can see I've got the different IPs configured in here, same associated port. And if you go all the way down, you can see that I have 50 RTUs configured in this session. So imagine using a version prior to 2.30. It would take you forever in task mode to create all of these instances on the configuration wizard with all the associated points. It would take you hours. And now with a command line interface, you can readily create a project and launch said project. The upper menus are pretty much similar to what you've seen before. Not too much has changed. Under the DMP3 LAN WAN protocol, because I am using a loopback, I have to disable UDP listen. But the other options are the same. I need a placeholder for testing, although it's going to always default and refer to whatever's specified in your exchange list, just like prior. So I've got a placeholder, which I used the very first IP address I had. Again, it's not relevant, but this is tied into the previous version, so it's expecting some sort of entry there in order for you to start operations. And once I've specified all of that, choose OK. Scroll up, and some of you may be using an older version of ASE2000 Testset. In those older versions, you didn't have in exchange mode, you didn't have the highlight capability, but you'll notice when I launch the simulation, or actually start the simulation, I've already launched it, it will highlight as it's communicating rapidly on screen. So all of these that are enabled for transmit and for the RTU, it would be responding to the controls from the master and highlighting it accordingly. So I have the RTU on the right and the master on the left. I start my RTU. My timeline is incrementing. So now I have 50 RTUs listening on their assigned port with their given IPs. And on the master side, it's utilizing that same configuration that I created from the project. So in this command prompt, I'll have used this command line clause twice to launch 2 instances. So now that I've got my RTU listening, I can start on the master side. There is one thing I want to point out, and before I begin, I am simulating 50 RTUs with ASE2000. Real time, it is not practical or feasible with all of these rapid communications to look at your line monitor view and try and perform analysis. Post 2. I believe it's 2.28. Forgive me if I'm on or off. It's one plus or minus one version on that. We introduce a rolling file archive. The rolling file archive is going to be instrumental when you're performing SCADA cutover testing and assessment. Let me show you that real quick. Up top, we have a capture directory. Pre 2.28, it was just the database. So you had the database capture. It was limited to a maximum of 25,000 messages. And once you approached or hit that limit, that was all that the application could capture at that time. So if you weren't monitoring it real time and managing it, you potentially could have more communications that you didn't capture. And so one of the newer features is the rolling file archive. The rolling file archive allows you to create up to 10 additional files to this capture and write them to a specified directory. That directory, and here I have validate chosen, that directory is specified up top, the same as where you would specify your event log prior. So if you go to events here, I would have to choose a path and specify a file name and path for my rolling file archive. Let me see if I can navigate to that real quick and show you what it looks like. And automatically it will, if you use the default setting, you specify a name, it will create 10 additional files without the user having to manage that. So you can leave a laptop in place on that communication segment and capture a multitude of communications, tens of thousands of messages. Here you can see I filled up my directory. It's just over a megabyte. So once it hits that limit, it will automatically create a secondary file. This would be the second, third, fourth, all the way up through file number 10. You can extend that in the upper menu that I showed you. So that's going to be instrumental for your analysis. And then I would take advantage of our message filter capability in there to look at particular communication sequences of interest. Back to the demonstration. The RTU is listening, and I just simply start the master. Give it a second. Should begin here. And as you can see over here on my RTU side, it's rapidly sending communications across all of those specified RTU addresses. Let me just expand this for you. And I could scroll down through the list and see which exchanges are being transmitted. And if I scroll all the way down, you can see there's RTU 23 or 14, 15, 16, 21, 22, 25, all the way down, RTU 44, and there's RTU 50. So I'm scanning single bit binaries, 2-bit binary inputs, analog inputs across 50 different RTUs, and I'm simulating those same real time. And if I needed to expand this simulation, I would simply create another instance of ASE2000, and in the command line, I would reference that uniquely. It would be a different project files, and that project file would have those unique RTU IDs in it, and the instance would include those in that particular session. It's the limitation again is 50 RTUs per instance, and I would highly recommend use your rolling file archive with this new feature set so that you can capture any and all communications for your validation and analysis needs. And that's a multi-RTU simulation with ASE2000. Let me see if there's any questions here. Does anybody have any questions on that? We are recording this webinar today, so it will be available on our website. And if you have any questions that I don't get to in the session or don't particularly see at this time, I'll be sure to respond via email follow-up to you. Any questions? Oop, here we go. Sorry. All right. Runtime error. Let's see. How can you generate the errors such as CRC, application mismatch, etc. on the RTU? In your RTU instance, you can force errors. Let me see. You would specify a forced error in your CSV index. Let me see. I'm going to stop this real quick because the lights are getting to me. 1 second. Yep, stop. That's not the one. It's this one. And let's see here. I'll try and follow up directly with that message with an example in email. Can you filter out your class 1, 2, 3 data? You should be able to filter out any communication captured in the test set. In there, you can, when you run or display the message on screen, since we are using exchange mode, let me just go up to the top. I'm going to answer the first one. For display, you would have enabled exchanges only would be visible. Of course, all of those are enabled that you saw on screen, and this is in task mode. So let me close that and go to the other session. Here in this on screen, if I received a class 1, 2, 3 command, I could filter that out. So if that exchange is listed here, and it should be down below, class 1, 2, 3, 0. This is how you would effectively filter them out by disabling your display flag. So you can display, transmit, or generate an event. So by enabling the event flag here, you could generate and force individual errors. Let's see what else we have. Well, there's a lot of questions here. 1.56, this is a version 2 demonstration. Version 1.56 does not support simulation of multiple RTUs as I've demonstrated today. You can do a select few, but it's incredibly limited, so it would just be a handful supported in 1.56. Yes, the same process is applicable to Modbus. And for a 1K file, how many data points and updates can be recorded? It varies. As far as your capture is concerned, just like with any and all communications across different hardware interfaces with a different number of devices with different configurations, it's all about how much data you're returning, how fast you're returning. So it's actually file size limited. It's not limited by a number of points. So those return messages on heavily configured or let me re-specify, on an RTU with larger configuration of point types and points would be a much more sizable payload than say like a level 1 outstation, which is just measuring select few inputs. So it's going to vary. Let's see. Does ASE support up to 50 RTU simulation for UDP? Yeah, UDP or TCP, it's not limited, so 50 would be supported per instance. And it says, is there an ASE2000 demo software available in order to test the feature set? Yes, anybody can download the present version or any version of ASE2000 version 2. And once you download that and launch the application, the first step is for it to look for a license. We license via our hardware accessories or a software solution. And if it does not detect a valid license, it'll prompt you to request a trial version. And when you request a trial version, you're required to fill out an online form that you send in with your name, your company information, your email address, etc. Once we receive that, we'll send you a trial license with a limited number of executions, like basically 75 um, executions, and you can run that basically I believe it's every 5 or 10 minutes you have to restart it, so that'll count as a single execution. Yes, we do support UDP communication for multiple RTU. And let's see if there's any other questions on there I missed. Forcing errors, we answered that. Filtering. Yeah, there was more than one question for UDP. That's it. We have any additional communications? I see some raised hands there, but I'm assuming those are applicable to the questions. Victor, yeah, I saw your question, Victor. Nicholas, let me see if I answered Nicholas's question. Nicholas, did you enter a question in there? I don't see you in the chat. Bhavesh Kumar, let's see, yeah, I answered your question as well. Can you explain how serial communication is encapsulated in TCP? So in the test set, once you select a protocol, let me just go to my RTU session here. Let's say I specify DMP3 serial. Up top now it represents serial protocol. This is my default exchange list. And all that's required after that is up in the upper menu, tools and properties. Now that I've enabled a serial protocol, I have to enable the terminal server functionality now and specify my host and port utilized for that TCP/IP communication. And all the communications that I would send from my test set would be serial message format, and they would be default or not they encapsulated by TCP/IP communication once I enter those parameters. That's all that's required. We support all serial protocols except for one, and forgive me off the top of my head, I don't remember which one that was, but it's a legacy bit protocol, which is listed in our, it should be listed in the help manual, whether or not that's supported. And what else do we have here? Any new questions? That's all I see. I owe a follow-up message to you, Victor, on the forcing of errors, and that's it. If any of you have any additional questions or comments, please feel free to reach out to sales@ase-systems.com, or all of our information's on the website. If you wanted to fill out a web contact request, you could do so. Otherwise, my name is Larry Price. It's larry.price@ase-systems.com. You can send me an email directly or to our support group. And we'll get back to you. Thank you, everyone, for joining us today. Hopefully, you're excited about some of these new features. I think that many people are going to take advantage of the rolling file archive capability, both in SCADA cutover and day-to-day testing. That's been a feature that has been long sought after, and expands well beyond what we were capable of prior to 2.30. So if you're interested in purchasing or an upgrade, just let us know. And thank you all, and have a good day.